I'm going to talk about these things, the railway context, just to give you a flavour of what Network Rail and the rail industry is about. Sustainability, a bit about that, because I think some background is needed to bring people up to speed on that. History lesson to do with the railways. Yeah, I enjoy that bit. I don't know if anybody else does. Interconnectivity, the future, and some comments, some challenges, and other things that are being recorded at probably John Dora's view rather than Network Rail's view. Context, yeah. Network Rail does all this. We maintain, enhance, renew the existing network. 23,000 culverts, 250 miles of underground watercourses, 25,000 kilometres of major earthworks, some fairly big numbers here. 38,000 bridges, we're the largest single bridge owner in the UK. I think I'm right in saying we own the largest single bridge as well. So a lot of stuff that works together and gets people and goods moving around the country. Rail operations, we run more trains across Britain than are run in most European countries. 24,000 trains per day. It's a couple of years old now, so I'm thinking it's probably more than that just now. More than these countries all combined. Half as many more than France, 60% more than Italy. So lots of things going on all the time. I bring it back to last year's McNulty report on rail value for money. Great British Railway lacks best practice. The whole system approach is compromised by silo thinking, and McNulty said, and we're having difficulty in trying to work out where he got his numbers from, but cost savings around about 30% out of 11 billion spent per year, quite some staggering sums, etc., etc. There's a lot in that report, and a lot of it is based on perception, not backed up with hard facts, and people like the rail regulator are looking at the hard facts just now with us and the whole rail industry. But also looking towards a sustainable future. The European Commission has got a white paper out just now that talks about a 50% shift, modal shift to rail by the 2050s. That's staggering. If you look at the figures I just gave you, 24,000 trains, how are we going to sustain 50% modal shift over the next 38 years? It's quite a staggering concept. If you think we carry about 10% of all transport in this country, and a 50% modal shift. Is that 50% of the other stuff coming to us? Don't know, but you know, it's quite a staggering concept. Sustainability. A lot of things written and said about sustainability and different perceptions, but the concept emerged in the 1980s. World Commission, the Brundtland Commission, the Brundtland definition, Brundtland report, and it says there, the last sort of bullet point, says that it's about meeting the needs of the present without compromising the ability of future generations to meet their own needs. So we think in terms of carbon, we think in terms of natural resources, we think in terms of population growth. Staggering concepts here as well. What's this all mean? 3 pillars came out of the Brundtland report: economic growth, environmental protection, and social equality. And these have been cut in different ways by different people. We've got the 5 capitals there on the right, but sustainable development, we attempt to measure and balance these often competing, always competing probably, themes. Government is committed to the concept of sustainable development. DEFRA has a vision. The IC's looked at it about low carbon futures and a trajectory for 2050. I encourage you to look at these links. I think the presentation will be made available, but the links are going to be quite useful to get some of the background here. The IMEC, the institutions are all behind sustainable thinking. It's great at high level, but you talk to somebody out there just now shoveling ballast on the railway, he wouldn't know sustainability from timetable in some ways. Maybe I'm being a bit cruel there. Network Rail, we identified sustainability over the past few years. Last year's July 2011, not July 2001. I don't think the Romans had Network Rail, but last year the Corporate Responsibility Report talked about sustainability. 6 themes we picked up, including adaptation for climate change, which is what I've been focusing over the past few years, carbon reduction, waste, biodiversity, diversity, social diversity, and inclusion and accessibility. In engineering, that has direct relevance on carbon, adaptation, and waste, in my view. And I will keep referring to in this presentation the 4 Cs. We had a 2007 white paper on delivering a sustainable railway, and in that we talked about the 4 Cs: customer, reduction in dissatisfaction. Why do we always paint things negatively in the railway? Reduction in dissatisfaction by 90%, halve the cost of running the railway, percent's crept in there as well. doubling the capacity where required, and reducing carbon in line with government policy 50% by 2050. 2007 doesn't quite match what the EC is saying about 30% modal shift and all that sort of thing, but they're all aiming in the same sort of direction. The history lesson, yeah, this is one that I take out of a sort of flooding and weather presentation that I give, but it just gives you a flavour of where the railways come from. The infrastructure in this country is up to 180 years old. The original railway was built along river valleys because it was cheap, but the expensive side of it was that the locomotives weren't very powerful, so they had to be fairly flat. This lovely broad gauge 7 foot and a 1/4 inch gauge engine here worked on Brunel's Great Western Railway, could get up to about 70 odd miles an hour in the 1850s, but not very powerful, maybe about 200-300 horsepower. So the railways followed and crossed floodplains, viaducts like that in the picture, shallow gradients because of the lack of power in the engines, whereas motorways and roads actually go over the landscape, go round and over. Railways are now interwoven with all this other infrastructure, so there's a lot of interconnectivity there. But cutting through the landscape makes railways more vulnerable to things like the weather and climate change. Again, coming back to my particular work just now. Flooding, couple of pictures there. The Red River, that one there, that's the river Exe and Culm Creedy coming together just outside Exeter. That river there is the Great Western Main Line going to Taunton, and that river there is the old southern line going up towards Barnstaple, and it used to go down to Cornwall as well. So that river got out of its banks in 2000, the whole railway was wrecked. High groundwater levels give us problems with chalk cuttings. We've got that happening today. Chipping Salisbury Tunnel is closed because the water is high up. The Oolite aquifer for the Thames there is actually punctured by the tunnel, and the water is now going to the Severn catchment. Whereas we'd rather it went the other way to recharge groundwater levels in the Thames, but never mind that. And extreme rainfall gives us landslip problems quite a bit, like these pictures down here, where we get mudslides and things coming on the railway which can cause derailments. And we had a derailment last week somewhere up country where a train came out of a tunnel and hit a landslip. And we've had a line closure up towards Inverness this morning at Carbridge, where we've had extreme rain and another landslip. So vulnerable to weather because of its nature. The railway system, as in itself, I think, is much more sensitive today than it was 50 odd years ago. I've said water here because, again, it's where I've been working. But if you look at what we have now, we have signalling and switch control systems electronic based, whereas 50 years ago, levers and wires and rods. You had telephone wires on poles, so they were strung by the line side, but now they're in little troughs beside the line, are particularly vulnerable to cable theft as well. Trains had larger wheels. We had a sort of 3 foot diameter standard wheel in the past with white metal bearings on the end with an oil bath which could go through water, no problems. Roller bearings a bit more vulnerable now, and nowadays you've got wheels down to very small size to carry high cube containers and to have more equipment, underslung equipment, power equipment, heating, ventilation equipment, underslung. Put it through a flood, the whole thing stops. The Voyager train there on Dawlish Seawall, 2003 I think that was. It stuck there for a couple of hours while the rescue locomotive came down from Birmingham. This is down at Dawlish. Rescue locomotive at Birmingham, and you think systems. In the old days we used to have a little hook and a chain, hook it on and pull the thing out the way, but couplings on these things these days, they're quite sophisticated, and you can't just take any old locomotive and couple it up and pull it away. That one incident in 2003 cost us £107,000 in delay minute compensation back to the train company. And I'm not sure if the passengers on the train got much compensation. They were sitting there for over an hour getting battered by waves and gravel and everything, so it can't have been very pleasant. And of course that was a failure of the train because of the electronics, the salt water, etc., etc. Think system, yeah. Network development, 1840, 1848, by and large the network was built by about 1850. BR at its peak, 1948. Don't know if it was efficient, don't know if it was optimized, but there's a lot of redundancy around the network. If I look at the northeast here, some of these lines were washed out in a great flood in August 1948. But the railway managed to keep running because it had lots of other routes that it could take trains through. Nowadays you've just got the one line there and the one line here, taking trains up to Edinburgh and Glasgow. So there was lots of redundancy in the old days. And also, I think, with staffing, you had local gangs, you had local signalmen, they walked to work by and large. Train crew used to lodge over and take trains back, and we don't do that sort of thing these days. So there's lots of things we used to do in the past which helped redundancy, helped resilience. 2012, much thinned out. You can't really see the network very well there, but it is there underneath the root structure. Very busy around the conurbations, carrying more traffic than it ever has done on this core network. And I'll just remind you of the 4C challenge again, increase capacity against this thinned down network. Reduce carbon, keep the customer happy, and reduce cost. Some good challenges there. Some words about interconnectivity, and Professor Beckford's slides come up here. It's not just rail in itself. I mean, rail depends on road and the other sectors. We need energy, we need transport to get people to and from the stations, we need transport to get maintenance staff around the network. And it's not just in isolation. John said quite a bit about this earlier. We need ICT. Boy, do we need ICT to make things work efficiently. But I think there's a challenge that comes with all this. The railway is a system of systems itself. Generally, either all works or it doesn't work. And I'm thinking of Chipping Salisbury Tunnel and diverted trains today. There's a bit of redundancy there, but at least we can divert trains. But it doesn't always happen that way. It depends much on other subsectors. How many times have you been turfed off a train to be put on a bus? So we depend on highways as well. And as mentioned, how the infrastructure is quite old. Despite the best efforts, we're still congested. We're beyond the perceived design capacity. But I do ask the question, did design capacity exist when the railway was built? There's an embedded potential for systemic or cascade failure, as we do see, and the complexity of everything else means that we rely on ICT quite a bit more than we used to do, and must respond to the potential of climate change, which is quite interesting when you look at some of the figures over the next 30 years, never mind the next 100 years. Interconnected means risks. So where you've got railway passing road, yes, we have bridges, but we end up with certain incidents happening from time to time. Repairs on the railway can be widely disrupted because it's such a congested, busy network. And I've got a shot here showing some work on overbridges, so we're disrupting the local road network, not just the railway, but also when we do renewals and maintenance on the railway, like taking the back off an arch to strengthen it, as is shown here. We're stopping the railway for what, a weekend? Goodness, that's a long time. And people expect 24/7 these days. One set of challenges there about the sort of works we do. Another challenge is the silo thinking. Here, I pulled off the internet, the network rail management structure, asset management being one directorate, and all these others being sort of directorates or sub-directorates. And if you think about this lot down here, I work in this bit, engineering, where we're encouraged to look ahead long term. But my colleagues in buildings and civils, like my colleague Brian Bell, who's in the audience here, they're encouraged to look at the next sort of 5 years. And we've got all these disciplines, tend to be disciplines working in silos. So the signalling engineer might not know an awful lot about signal engineering, civil engineering, beg your pardon. The track engineer might not know an awful lot about civil engineering. But 30 years ago, when I started working the railway, I went through this lot. So I had a grounding in everything. Nowadays, we specialise very soon. And of course, we have all these other people, finance. We can't do anything without finance. And making the financial people understand the business case for X, Y, Z can be a challenge sometimes. This is just Network Rail. We've recently devolved the organisation into 10 routes. So you've got a national organisation, 10 routes that have all these things replicated. It starts to become a wee bit complicated. And then you add the 24 train operating companies, open access operators, freight companies and stakeholders. And it's a big, complicated machine with people doing the easy thing, thinking in silos. So we need to think about the 4 Cs against the legacy of the 180 years worth of infrastructure. And Chris Rogers, myself and others have been asking questions, in the longer term, do we actually look at some of our infrastructure and throw it away and start anew? Do we need to increase capacity by building new lines? But what about short life assets? They have a part to play in it as well, because power, signalling, telecoms, 15, 20 years, track systems, 40 years. Different asset lives all interacting. How do we tackle those? And how do these things interact? Who owns the interface? How can we think system? I'm just asking some questions. Who owns the interface? Who owns this intangible thing here called the wheel-rail interface? That wheel and that rail have a contact patch about the size of my thumbnail with lots of force in it. Now, we don't have anybody that owns that interface, so that's just an interesting question again. And this isn't the only one. We need to think about cradle-to-cradle design. And I've said value there, not whole life cost. I prefer the term value than cost, because cost makes you cut things, value makes you add things. The ICE paper, capital carbon versus operational carbon. We need to think whole life. New metrics that help us think about feedback mechanisms. So when we do something, we know how it changes whatever we're operating and how it then causes change in a big sort of feedback circle. We've done some good work on intelligent infrastructure. We're looking at component-based intelligent infrastructure, but not the whole thing. But what else? There's people trading skills, skills retention, knowledge retention, investment, discount rates, things that encourage long-term investment. We haven't got those just now. I think in network rail terms just now, if we carry out any investment, the discount rate we use is about 5 or 6%, which doesn't encourage long-term thinking. And governance within and externally, I come back to this question, who owns the interfaces, but not just within rail, but outside rail? Challenge number 4, perverse outcomes, really. Project delivery mentality. Project delivery is great. We look at delivering things to quality, time and cost in a finite length of time. But we're looking at projects within the sort of wicked problem concept. We've got an infinite continuum there. Are we ever going to rebuild the 4th bridge? You know, it's there. Let's keep it going. Now, lowest first cost is the sort of thing you get when you think about project delivery mentality, which is really good. Value engineering is really good. But we sometimes get projects de-scoped which mitigate against whole life value realization. Good example, some years ago, a lot of track works was being carried out on Network Rail, and we actually, because we couldn't afford it, de-scoped drainage from the track renewal project. As a result, some track systems only lasted 10 years. They should last 40 years. Why did they only last 10 years? Because the formation got wet. The ballast started to degrade rather quickly, and the whole lot fell apart. So another question, how do we keep adding value throughout the infrastructure's life? It's not lowest first cost, but we tend towards this because it's within people's comfort zone. Silo thinking is easy. The other question I posed down here, is design life, the concept of design life, a barrier? We design bridges to 120-year design life. What does that mean? I won't answer that. We also have done a lot of work trying to understand asset degradation. So we've got some tools that help us understand how assets, when they're built, they start to degrade, and you intervene here to bring its condition back up again. We tried that for whole life management ideals, and it gives us some idea of the sort of cost we might spend on certain routes with a certain level of traffic, balancing age and condition of assets. And for some assets, like, again, my good old favourite Dora seawall, we consider the weather and location in that sort of calculation. We've got some of these tools from the high-level whole life cost thing down to local decision tools for frontline managers just now. A lot of this stuff is based on, whoops, back again, the new measurement train inputs that we get. We have a lot of data that comes out of the new measurement train, and we can use those measures to tell us, target where the work should be carried out. And we use these outputs in models such as TrackX. TrackX is a particular model that tells us a lot about the wheel-rail interface and the forces that exist, and also how vehicles will react to track and track will react to vehicles. It's quite good looking at that one interface, but we've got aspirations to look at overhead line X. So how does the overhead line behave? Ballast. Here we've already sort of taken the rights for these names as well, because these are the things we might develop. Bridge X, ballast X, and so on and so forth. So we understand how parts of the system interact. Some things are thrown in here just to get some wider thinking going. Capacity compromises, things that make the railway capacity limited. Terminal stations. Terminal stations take up lots of capacity because trains have to come in, disgorge the passengers, get cleaned, and go out again. And I'm sure you've all waited in a train waiting for a platform at a London station at some time. It's because they take a lot of time. Wouldn't it be quite useful if the track could go at the end there and go into a big loop, and when the train went off there, it got cleaned and everything else. Train comes in, disgorges passengers, it gets out, another train comes in. Crossrail's great for that. Thameslink great for that. Trains come north and south, don't actually terminate in London, they get out of London. Ticket gates, I hate ticket gates. They're a real pain, but they're a great revenue protection device. But queuing up to get out of a terminal station is a real pain. Again, it's a capacity compromiser. Flat junctions at Didcot, where I passed through this morning, when my fast line train crosses the relief lines to go north to Oxford, you end up with a freight train perhaps taking up the line on the flat junction, taking 10 minutes to go through that junction. Trains can run at 2-minute headways, 2 minutes between each other, unless there's something like a flat junction in the way where you've got to wait while trains cross the lines. So we need flyovers, bridges, to take trains across flat junctions, or segregated railways, freight railways, passenger railways. Level crossings, delicate power systems. These things, goodness gracious me, a conductor wire is about that thick, taking 25 kV. Get high wind, you get problems. Get ice on it, you get problems. Think about the weather. Deterioration, fatigue and damage. Yeah, that bridge there carries a railway, it's been struck by vehicles, just wearing away the brickwork. Rust, fatigue cracks. Repairing these takes up capacity. Not forgetting the weather. And that's 2007 in Yorkshire, downstream from the M1. There's one of my colleagues standing there. I'm told he's at a safe distance. Well, he thought he was. Yeah, not forgetting the weather and how this is all going to change over the next 30, 40 years. Some solutions, yes. I can point to things like drainage, remediated embankments, targeted weather forecasted, digital mapping, emergency kit, reconstructed hillsides, and I put in system thinking. We're not good at that, but it's started to be something we're thinking about. We've got a systems team which I work in, but we think about systems being probably the piece of kit rather than the wider system thinking, which is what we want to talk about here. Now, vision of the future. If you think of a future railway, people tend to think of high speed, 250 mile an hour HS2, or this here's a tram train, runs on mainline railway tracks and goes into the town and goes around the streets. Great concept. Yes, I think they're part of the solution, but it'll be a mixture. So you'll have everything we got now, probably with some dedicated lines like very high speed, 250 mile an hour plus. You'll have a multifunctional core, so that'll be much like what we've got today. We'll have metro, suburban, rural railways, probably tram trains as well. We're trialling, or about to trial tram trains in the country. And I put dedicated freight because I think that's something that we ought to think of really hard in this country. Bringing it all together, system thinking should make all this work. Governance, interesting concept. I think we will have cross-sector governance, not just the railway looking after itself, but something much wider than that. New business models, new economic models. The current economic model is broken, I've heard people say. Long-term changes being fostered. Joint use of infrastructure, railway embankments as coastal defences. Well, we do that now already, but nobody recognises it. We could have had a pipe in Chipping Sodbury Tunnel taking water between catchments. Joint use. Central reservations taking tram trains, because trams don't need the high-speed alignment, so they can get onto road alignments. Redundancy across sectors would be facilitated, and metrics. If you can't measure it, you can't manage it. Metrics allows us to look at the feedback concepts and everything else. And differentiated standards will make things cheaper as well. We don't need the same heat-related standard for track that we have now throughout the country. We won't need that in the future for Scotland and the South East. We should have differentiated standards. And system thinking, again, makes all this work. Coming back to the 4 Cs, customers will like to travel by train. I do sometimes. I don't other times. Be part of an integrated solution. It won't just be, you know, I'm going down to catch a train. I'm going to have to go from here to Newcastle, and my iPhone or whatever will tell me this is the best way of doing it, and I'll have a timetable or a plan. It'll be passenger and freight friendly, always informed. Coming here this morning, I was working out if my connections would work. Great. And they did. Freight distribution redesigned for rails, so it comes out the factory, it's packaged in such a way and drops onto a rail vehicle and goes to its destination. System thinking makes this work. Technology will help us to reduce costs. Adaptation of assets to climate, prioritization by location using GIS. Now we're doing that already in Network Rail. We got surface water risk maps that tell us where water collects near the railway. We're using that to target drainage investment and earthwork investment, but we could use that to target problems with heat and track, and heat with people, and heat with line-side equipment. Joint infrastructure planning and utilisation, I touched on that a minute ago, but it won't be just us looking at the infrastructure, it'll be UK PLC looking at infrastructure generally. Over the next 20, 30 years, I think a lot of our short-life assets will be replaced, so we've got an opportunity there in terms of climate change to adapt them when we renew them. And that won't cost us anything. It might cost 5% or something, but it won't cost us anything compared with building something new to be climate resilient. It'll be just replacing something that's there just now. System thinking makes all that work. Carbon, a vision, no operational carbon in use. It'll be a carbon-free railway. We'll be making use of the existing infrastructure, so we're reusing and recycling the infrastructure, making best use of sunk carbon costs. It's all been paid for in carbon terms, so let's use it. Lightweight trains, yeah, no-brainer there. Signalling and driving optimized for energy and customer demands. We'll have transmission-based signalling. It will be based on radio signals, and trains will know where they are. And the optimization there is making sure we have tight headways, demand, supply, all linked together. Sustainability in action. Capacity, the signalling I just mentioned. Trains know where they are, travel at speeds and headways linked to braking distance. 2-minute headways, but when you come to that flat junction, you've got to do something to try and increase capacity at those junctions, terminal stations as well. We'll remove those bottlenecks and vulnerabilities, weather vulnerabilities, system vulnerabilities. We'll understand how the assets behave when subjected to some kind of shock. Monitoring, we'll see intelligent, smart infrastructure knows what it's doing. We will repair things before they actually fall over, and we will repair things without actually stopping the railway 24/7. System thinking again makes all this work. While I was preparing this, I came up with about 6 different mind maps, and I thought, I can't see all this, but I've stuck it down there. You can read that at your leisure. And it's not a proper sort of cloud map. I've just sort of put them in capitals and things and bold what I felt like, just to make it look clever. So the summary, the future railway will be a multifaceted railway, part of an integrated transport system. The 4 Cs will drive change, drive technological change. We will have quite a bit more redundancy in the railway system. We will be more reliable than we are now through smart and intelligent systems, but we'll have this governance. It doesn't just look at the railway as an entity in itself. It will look at the railway and its infrastructure in the context of UK infrastructure. Technology, knowledge will be key, but we need the systems thinking to make it all work. Thank you.